Welcome to the Practical Knobology module. I am Rico Estrella. Before taking this module, one should have already finished with the following modules. Number 1, Basic Ultrasound Physics by Dr. Quintos. And number 2, the Knobology module by Engineer Santiago. The Practical Knobology module is all about understanding the basic knobs and buttons on your ultrasound machine. And hopefully, by the end of this module, you would be able to use any ultrasound machine with ease and at the same time produce clear and precise images for documentation. Ultrasound machine controls can be very intimidating at first. There are dozens of knobs and buttons which make things very confusing at first glance. Well, fortunately, all ultrasound machines have the same basic settings, and I will go through each of them in this module. Not all ultrasound knobs and buttons are important for basic imaging. I will be showing you a simple 8-step approach applicable to any ultrasound machine. This simple approach will help you optimize ultrasound settings to drastically improve your image quality and, at the end, document and do precise measurements in your images. These are the 8 key steps that I will be discussing. It covers powering up the machine, to adjusting the image, and then finally to image capture and basic caliper measurements. I will go through these steps one by one. In almost any ultrasound machine, the buttons and settings are very similar. Only the layout and access to these buttons are different, especially now that the newer machines offer touchscreen capabilities on their monitors with less physical knobs. I will try to give you visual examples to each of them. Let's start simple. How to turn on your machine. This is the universal symbol for the power button. This symbol applies to most, if not all, ultrasound devices. And most machines have mechanical switches for this. And these are a few examples of where the power button would be located in some GE and Sonosite machines. Pressing the power button may sound very simple, but what do you do if the machine doesn't start up properly, doesn't turn on? Just like in any other electronic machine, you must check the power supply, check the cables, are they properly plugged in? And for rechargeable machines, check if it's adequately charged. Addressing these issues usually fixes the problem. If you are unsure, just wait for an ultrasound technician to help you with the machine. Selecting the proper transducer to use is a very important, if not the most important step in using the ultrasound. The ultrasound probe you should use should be based on the application you are performing. In general, transabdominal ultrasound applications like FAST and HBT ultrasound uses the low-frequency curvilinear probe like the third one from the left in the picture. Soft tissue ultrasound, on the other hand, like for breast, neck, and vascular ultrasound, uses a high-frequency linear probe like the first one on the left in the diagram. In the picture, the second probe is the one they use for 2D echo, and the fourth one is the transvaginal ultrasound probe. Switching to the correct probe in modern machines is usually done electronically. A lot of modern machines have multiple transducers are called all-in-one machines, designed for use in a variety of applications. You just have to press this and the select transducer button as in the examples pictured on the right. The icon would usually look like this in most machines. And these are other examples of how the transducer switch or selection button is presented in other machines. And as you can see, they are very similar. As you can see in these machines, there are multiple transducer ports. Electronic probe switching is invariably present in these machines. Switching probes in some instances would require you to physically remove the active probe and then switching in the probe which you are going to use. This is sometimes necessary for compact machines where there are a variety of probes, but the actual physical port is just one or two. The third step is selecting the appropriate application preset. Now, ultrasound machines usually come with application presets, which make it a lot easier for faster for the end user. This is very similar to preset equalizer settings in a typical stereo or audio system at home. In the audio equalizer, you could select rock, classical, jazz presets, and while in the ultrasound machine, you could select cardiac, abdomen, OBGYN settings, soft tissue. In most machines, these settings are pre-programmed by the manufacturer. Although selecting the application preset is optional, no, these presets automatically set up the ideal depth and gain for your specific application. In some machines, the ideal probe is also automatically selected. Selecting a preset would give the user a good starting point in carrying out the ultrasound examination. One would then need to fine tune the ultrasound image using steps 4, 5, and 6, and 7, using depth, overall gain, near far field gain, and time gain compensation, and then focus. Now, do take note that not all machines would have adequate presets, so one would have to do this image tuning manually. Before I continue with the next slides, now let me emphasize to you that steps 4, 5, 6, and 7 are frequently done several times during a single scanning session. And this would be dependent on how many structures at different depths you are interested in. So this is not usually just done once uh, during an ultrasound examination. Step 4, depth. Depth controls how deep the ultrasound waves returning to the probe are detected. Increasing depth allows the user to see deeper into the patient. And of course, decreasing depth helps you focus more on the superficial structures. This is an example of the button layout for depth settings on the Sonosite M Turbo ultrasound machine. A numeric scale on the right of the screen is often present, which would orient and guide you as to the depth of the image you're viewing. A good rule of thumb to use is to start scanning using the maximum depth at first. Landmarks would be more easily identified in a deeper scan, and then starting the scan with a very superficial depth would frequently disorient you, and a lot of structures may be missed. And then while scanning, you can then reduce the depth until the structure of interest is centered. Decreasing depth will then help you focus and magnify the structure you are interested in. This is especially helpful in doing accurate caliper measurements. Step 5, adjusting overall gain. All ultrasound machines have an overall gain setting, which would be a knob or a button. Increasing overall gain makes your whole image brighter, and decreasing overall gain makes your whole image appear darker. In this example, increasing overall gain makes the whole image brighter. In contrast to the image on the far right, decreasing overall gain makes the whole image darker. Going back to my previous analogy with audio systems, the overall gain control is much akin to the main volume control for audio systems. Increasing or decreasing the the gain affects the whole image on the ultrasound. Very similar to the master volume. This is an example of gain optimization. On the top left, the image is seen to be too dark. This image is undergained, and we would need to increase overall gain. The top right, on the other hand, is too bright, overgained. So we need to decrease overall gain. The bottom image shows the optimal gain setting. Step 6, near or far field gain and time gain compensation. Now, these settings allow you to fine tune and adjust gain at specific depths of your ultrasound image. Now, most ultrasound machines would have one or the other or both. The near far field gain adjustment system is the simpler of the two. Machines like this one from Sonosite, allows you to fine tune gain in a simple manner. The near field is the top half of the image, and the far field is the bottom half of the image. Simply put, if you want the upper part brighter, then you increase the near field gain. And if you want the bottom half brighter, then increase the far field gain. Time gain compensation, or TGC adjustment, is very similar to near far field gain, but on the other hand, is more specific. It allows you to further adjust the gain at specific areas of the screen. And again, going back to my previous analogy, adjusting time gain compensation is very similar to adjusting your home stereo equalizer system. They actually look very similar to each other as in the images provided. Time gain compensation has adjustments corresponding to every depth, just like an audio equalizer system has adjustments for every audible frequency. Now, in this example, the time gain compensation at all depths are set in the middle. So look what happens when the time gain compensation is decreased to zero at the middle of the screen. There is corresponding absence of echoes in the middle of the ultrasound screen. So after adjusting gain, step 7 would be adjusting focus. Focus is the last setting you can use to optimize your ultrasound image. Adjusting focus simply means that you are maximizing resolution by concentrating the ultrasound waves at a specific depth. In this example, focus is indicated by the small green arrow at the right side of the image. This is usually superimposed on the depth markings. However, some machines have autofocus built in. So these machines do not allow focus adjustment anymore. So for the last step, step 8, after image optimization, we go to the documentation and measurement step. There are three essential and most commonly used functions in documentation, namely the freeze button, the cine or review function, and the caliper measurement function. And these are available in all ultrasound machines that I know of. The freeze button is probably the most frequently used button in ultrasound studies, which is why it's the biggest button in most ultrasound machines. It allows you to freeze the frame or take a snapshot of what you will be able to view, and so that you could actually examine it in greater detail while resting the ultrasound probe on the holster. Freezing the frame also allows you to do the measurements that are needed for your specific study, and printing could also be done when the image is frozen. These are some examples of button layout for the freeze function in different ultrasound machines. The Cine Review or scroll back function is a very useful function on most ultrasound machines. And once you have frozen a frame, you could scroll through 10 to 60 seconds worth of image data, which you can review. With these stored images, you can freeze other frames and do measurements without redoing the scan on the patient. The top image is an example of the Cine function being looped. And you can usually find the Cine review function near the freeze button or on the screen for touchscreen devices. The caliper measurement function is the last button that I'm going to talk about, and is the tool you are going to use for accurate measurements. Once you have an image frozen, pressing the caliper button summons a caliper on the screen, usually marked by X's or other letters, and then you could then manipulate these endpoints using the trackball or trackpad on the ultrasound machine. For each of these endpoints, you press set to finalize the measurement. The the top example on the left measures the IVC diameter. Now take note of the two crosshairs, letter A's, pala, which mark the endpoints of the measurement. No. The example on the bottom shows a dilated common bile duct in cross section being measured in 2 dimensions. So thank you for your kind attention in this short module. These are the references I used in the making of my presentation. I encourage you to check these out also for better understanding of the subject matter.